My name is Tim. I'm in my last year of my undergraduate degree and I'm taking Mechatronics Systems Engineering.
I'm Richard Arthurs. I just finished up my second year in Mechatronics.
I'm Shahira. I am in computer engineering. And what year am I in? That's a good question.
My name's Brian Fisher. I'm a fourth year MSc engineering student. That's Mechatronics Systems Engineering.
Hi, my name's Toby. I'm a first year engineering science student, hopefully going into engineering physics.
I want to do something space related. I want to do something challenging, and I want to do something that involves the SFU community. And then I learned about the Canadian Satellite Design Challenge, and all these things came together. And then I met Toby, and we decided to start the club.
I've always been interested in space stuff. For me, seeing Mars rovers and documentaries about them was what actually got me interested in engineering in the first place. And then I kind of went in sort of a robotics direction with mechatronics, and then seeing that we had a club focused on space-based engineering was perfect opportunity. Super excited for it.
I like satellites. I've always wanted to work in the astronomy and space industry. That's my end goal. So learning that we are starting up a club to build a satellite is just a dream come true.
Yeah, so getting a satellite out there is something that's a pretty big achievement. It's definitely a very exclusive thing that very few people are capable of doing, let alone get the chance to do so. And it seemed like you guys had a ton of people interested in doing that, and we right now do have quite a lot of people working and putting a lot of effort towards it, so it's definitely something to be a big part of.
Oh, because I made it.
Okay, right. Why did you start this club?
Okay, yeah. Because I like space.
Right.
Everything space, astronomy and spacecraft. And hopefully in the future I'll work on space-related industries, maybe spacecraft.
I've mostly been on the computing team, but I've helped kind of with overall integration and power stuff too. So I helped write the scheduler to kind of deal with all of our tasks and make sure everything is synced up time-wise. I've done some interfacing with the various sensors that we have on the balloon. I made the board to kind of distribute the power and signals to all the sensors and the various computers on board, and that kind of thing. Lots of integration work.
So the Canadian Satellite Design Challenge starts in September. Until then we have some time, and we decided to work on something else. We decided to work on the weather balloon because it's the closest we can get to space with the least amount of effort, and for the past few months we've been working on the high altitude weather balloon, and it's actually getting launched in a week.
Alright, so this here is for the weather balloon. So it's in one of the preliminary steps before we start doing actual satellite things. This is the payload at the bottom. It's a very insulated styrofoam box in which is going to contain all the electronics, the batteries, and the camera for weather balloon test. I also have the parachute here, in which we're going to be using. Very simple high altitude parachute. High altitude just means that any of the materials that it's made of aren't going to get damaged if it gets frozen or such due to the conditions of the high altitude. And so this is just a collaborative effort of the structural team.
So right now we're working on a high altitude balloon. It's sort of analogous to an orbiting spacecraft in terms of altitude, distance it is from us, and the technical requirements that we have to meet. And it's really a stepping stone right before going to spacecraft. We want something a bit easier, but something similar to, and weather balloon or high altitude balloon was our best idea.
So what have you done so far?
So mostly I've been working on the computer aspect of the weather balloon. So we have a bunch of little modules, you can call them, little different units. With our different units, we would do things like something that I personally worked on was, let's say, once the balloon lands on ground, it's going to send out the GPS signal that this is the area it's in, but when we're actually doing recovery for it, the balloon so instead what the balloon detects when it's it's in that state, then it basically a buzzer goes off, and every like once every few seconds, it'll send out a very loud sound, so that'll help us track the balloon faster.
Oh,
Yeah.
so the sound will make it easier to find.
Yeah.
So what's the purpose of this weather balloon? Just to
Um,
test sensors? So what's-
There's multiple purposes. First of all, it's just first project for us as a club to start working together, to learn how to work together, to learn how to make a project succeed. Then you want to test some of the hardware, radio communication sensors. And then it's also a good promotion for the club. We're gonna make video. We're gonna get the video out of the weather balloon. We need a lot of sponsors for the actual satellite design, and hopefully this video will help us gain some attention.